Good evening, everyone. In today's class, we're going to cover the remaining sums of 7.5 x's based on partial fractions. So this is question number 8, which is x divided by x minus 1 the whole square by x plus 2. So we have a square term and a linear term. So we break the sum like this. This is the form we break the sum. A by x plus 2, b by x minus 1, c by x minus 1 the whole square. Now take LCM. LCM will be x minus 1 the whole square into x plus 2. The numerator will be a times a into x minus 1 the whole square plus b into x plus 2 into x minus 1 plus c into x plus 2. So the denominator will get cancelled with the denominator on the left side. Remaining is x divided by the numerator term. Now, I told you already that we have to utilize whatever the factor given in the question first to find the value of a, b and c. So we first utilize x minus 1. So if x minus 1 equal to 0, x equal to 1. Substituting x equal to 1 everywhere in the place of x, we get c as 1 by 3. Then I'm using x plus 2. So x is equal to minus 2. If you take x as minus 2 equal to a into minus 3 the whole square, b into 0 and c into 0. This way we find the value of a also. So out of 3 constants a, b and c, we found the value of a and c. Now we need to find b. Well, do not take arbitrary values. Compare the coefficients now. Now the highest degree that can come on the right side is x square. When you expand it, you will find x square as the highest degree, square as the highest degree. Whereas on the right side, it is just x power 1. So there is no x square term here. So when you expand this mentally, not there, you'll get a into x square minus 2x plus 1. And over here, b into x square plus 2x minus 1x, that's x. And then plus 2, minus 2. Plus c into x plus. It is not necessary that you have to expand them. You can do it without that also. So when I compare the coefficient of x square, here we have x square, here we have x square, and there's no other place where we have x square. And on the left side, we don't have an x square at all. So it is 0. So when you compare the coefficient of x square, you get 0 equal to a plus b. A value you already found. Substitute that. With this you get b as 2 by 9. So a is minus 2 by 9, b is 2 by 9 and c is 1 by 3. Now substitute these values over here. A is minus 2 by minus 2 by 9 into integration of 1 by x plus 2 dx. B is 2 by 9 of integration of 1 by x minus 1 dx. And c is 1 by 3 integration of 1 by x minus 1 the whole square. This will be log right away. So you get log of x plus 2 for this. This will also be log. Whereas the next one, if you take t as x minus 1, dt will cancel dx. Therefore, using substitution, we get 1 by t square into dt. Take it up and integrate. So it's t to the power of minus 2. T to the power of minus 2 is t to the power of minus 2 plus 1 by minus 1. So minus 2 by 9 log of x plus 2 plus 2 by 9 into log of x minus 1 plus 1 by 3 t to the power minus 1 by minus 1 plus c. So 2 by 9 into log x minus 1 by x plus 2 and then plus 1 by minus 1 by 3 t, which is x minus 1 plus c. So next question is question number 9, same pattern. X cube, well, if you see, the denominator is not in the grouped form. So let's group them and get them in the simplest form. So I'm considering only the denominator, which is x cube minus x square minus x plus 1. Group, taking x square common out from the first two terms, it's x minus 1. Then minus 1 common out, x minus 1. So we get x square minus 1 into x minus 1. X square minus 1 is x plus 1 into x minus 1. And we have another x minus 1. Therefore, x minus 1 the whole square into x plus 1. Now the denominator is 3x plus 5 divided by x minus 1 the whole square by x plus 1. Something similar to the previous sum. So a by x plus 1. It can be a by x minus 1 also. Not necessary a must have only x plus 1 as a denominator. It can be a by x minus 1, then b by x minus 1 the whole square, c by x plus 1. So you can separate it however you want. Plus b by x minus 1 and c by x minus 1 the whole square. Now take LCM. X minus 1 the whole square into x plus 1 is the LCM. So a times of x minus 1 the whole square, b times of x plus 1 into x minus 1 and c times of x plus 1. And the denominator will get cancelled with the denominator on the left side. So therefore, we have only this. Now once you come to this point, I think you all will know. Take x as minus 1, you will be able to find one of the three variables. Take x as 1, you will be able to find the other variable. And to find the third variable, start comparing. Once you find the comparison and get the third variable value, apply it over here and start integrating them. So next question, 3x minus 1 by x plus 2 the whole square. This is question number 14, similar to this type. A by x plus 2, b by x plus 2 the whole square is the way we separate this. So when you take LCM, it would be x plus 2, simply x plus 2 the whole square. So a times x plus 2, b times just b. So this side, x minus 1 by x plus 2 the whole square. X plus 2 the whole square get cancelled. So 3x minus 1 is equal to a into x plus 2 plus b. Use the factors that is available. So let x is equal to minus 2. When x is minus 2, it is minus 6 minus 1, a into 0 plus b. So b will be minus 7. Now the next thing we have to compare. So when we compare the highest degree. And you see x power 1 is the highest. So it's 3 equals a. 3 equals a. When you compare the coefficient of x terms. So we found a and b. Substitute a and b here. So 3 by x plus 2 minus 7 by x plus 2 the whole square. 3 out, integration of 1 by x plus 2 minus 7 out, integration of 1 by x plus 2 the whole square. 1 will give us log x plus 2 and the other one will give us t substitution method 1 by t square, so it moves up as t power minus 2. So it's plus 7 t power minus 1 log 3 log mod x plus 2 minus plus 7 by x plus 2 plus c. So the next type is 7th one, where you find that the denominator contains x minus 1 and x square plus 1. X square plus 1 is a non-factorizable quadratic equation. Non-factorizable. When I say non-factorizable, it means no real root exists for that. Hence, we separate using the last type. So it is a by x minus 1 plus bx plus c by x square plus 1. This is how we separate when we get a quadratic function which has no real roots. Then the usual process, take LCM, x minus 1 into x square plus 1. So a times x square plus 1 bx plus c into x minus 1. On the left side it's x by x square plus 1 into x minus 1. Denominator will get cancelled. So x is equals a times x square plus 1 into bx plus c into x minus 1. The only available factor here is x equals to 1. Using x minus 1, we get x equals to 1. So I'm going to use that first. So let x equal to 1. So you get 1 is equal to a into 2 plus 0. So a value is 1 by 2. And that's all. I don't have any other x terms that I can assume from the question. So next is to start comparing the term. Let us compare x value is minus 1, not plus. I mean x minus 1 equal to 0. So x is equal to 1. X minus 1 equal to 0. Comparing x square terms, we get 0 equals a plus b, because bx into x will give us bx square. So b, since we know a value, b will be minus 1 by 2. Next we compare x terms. Once x square is over, compare the coefficients of x terms. X terms I get 1, because on the left side we have x, and here we don't have any x, whereas here when I multiply bx with minus 1, I have a chance of getting an x, and when I multiply c with x, we have a chance of getting an x. So it is minus b plus c, and b value we already found. If we substitute, that will be 1 by 2 plus c. So c equals to 1 by 2. So a is 1 by 2, b is minus 1 by 2, and c is 1 by 2. Now substitute it back into the question. We get 1 by 2 integration of 1 by x minus 1 plus dx, which is minus 1 by 2x, plus 1 by 2 by x square plus 1 dx. Now that's half integration of 1 by x minus 1, and then minus half x by x square plus 1 integration, and then plus half integration of 1 by x square plus 1, everywhere dx. Now the first one is log, so you get half log mod x minus 1. The second one is substitution, because when you take x square minus 1 as t, dt will cancel x, right? So it will be 1 by 4 into log of mod of x square plus 1. Whereas for the third one, it's a special integral, 1 by x square plus a square. So this will be tan inverse x plus c. So what we completed now is question number 7. Based on that, we can do question number 13. 7 and 13 are same type, because even here we have a non-factorizable quadratic equation. Whereas question number 10, question number 11 are based on the same types that we covered already. X square minus 4 we can split as x plus 2 into x minus 2, and then we can follow the way as we did the third question. And then question number 10, we split x square minus 1 as x plus 1 into x minus 1, and we follow the same course. Now the next type which I am going to opt for is question number 6 and question number 12. Question number 6. Question number 6. 1 minus x square by x into 1 minus 2x. Well, when I started partial fractions, I did say that degree of the denominator must be numerator must be less than the degree of the denominator. Whereas here, the degree of the numerator and denominator happens to be the same. Therefore, right away if you start partial fractions, you might miss some terms. So therefore, proceed with long division, break the term and then start partial fractions. So 1 minus x square, we will write it as minus x square plus 1. X into 1 minus 2x as it is. I just multiplied them. Now dividing this by this, the long division, only to an extent that we come to a remainder where the degree is lesser than the divisor degree. That's all. You don't need to complete the whole division. Just come to a point where the degree of the remainder is less than the degree of the divisor. So with one level of division, we come to a point where the reminder's degree is x power 1, whereas it's square here. So I'm stopping it right over here. So instead of writing like this, we can write this in a mixed form. So which is quotient plus remainder by divisor. Quotient is 1 by 2. Remainder is 1 minus half x. And divisor is x into 1 minus 2x. Now let's start integrating it separately. This one is direct integration. Whereas for this one, we have to proceed with partial fractions. Find the value of a and b, substitute it back, integrate, you will get the answer. But one thing should be kept in mind. Once you apply a and b value, over here we get log. But when you take log, we are using substitution. So we take t as 1 minus 2x, so that will generate minus dt. So make sure that there is a minus is considered before you write log. Minus half. So once you find a and b value, first by using x as 1 by 2 and then by comparing, you end up by getting a as 1 and b as 3 by 2. Substitute it, start integrating. But as I said in the beginning, you are going to follow substitution when you're integrating this particular term. So do remember that you get a dt by minus 2 in the place of dx. So eventually that will take you to minus 3 by 4 log mod of 1 minus 2x. And this is just the answer for I2. I1 is the separate term that we found it already. So I1 is integration of this. So that will be x by 2. So at the end, the answer will be like this. Question number 18 is a unique model and it's an important sum. Here we use a dummy variable because direct partialization is not possible as it will be too lengthy. So take a dummy variable t as x square. So t plus 1 into t plus 2 by t plus 3 into t plus 4. So we get t plus 1 into t plus 2 as t plus t square plus 3t plus 2. Whereas denominator is t square plus 7t plus 12. Now since the degree of the numerator and denominator is equal, direct partialization is not possible. So let's divide it and break the numerator. So this we can write it as 1 minus 4t plus 1 by t plus 3 into t plus 4. Now let's partialize only this. So separate as a by t plus 3, b by t plus 4. The normal process of partial fractions will be followed through. T equal to minus 4, we get b equal to 6. T equal to minus 3, we get a equals to minus 2. Once you find a and b value, substitute it back, and before you integrate, take t as x square. Remember, before integration, take t as x square and then you start integrating. So with this, I'm done with the important models of partial fractions. The remaining will be covered in the next video. Thank you.